Y equals arc cos x. Let's just remind ourselves of this arc cos function then. Here's the cosine function if we were to sketch it. Start 0 is 1, and then that's pi over 2 there, and this is pi, and then it's just the same on the negative side, isn't it? So there's our cosine function. This is y, and this is x. So let's interchange the y and the x axes and flip them around. So I'm going to pull that off the page and twist it over and put the x-axis vertically and label it y. Put the y-axis horizontal over this side and label it x. So I've twisted it over, and you can see that the function is going to look a little bit like this, isn't it? Agreed? So there's the belly, so to speak, and there's the belly there. And it goes back here and back here. Now if we remember the principal value range on the y side here goes from 0 to pi. Okay, and then we get our arc cos. So this part down here isn't included. So I better remove that then. Now that I've sketched it, we can see what's what. So we can come around like so, and then back up there, and that's the y-axis. Okay, so now we can see that. You can see that it goes from 0 to pi, which is here, and here sine of y is greater than or equal to 0, isn't it, from 0 to pi. So that's something to bear in mind when we do this problem now, when we eventually have to square root something. So the sine y is positive is something to bear in mind, and the range. So this is 1 and minus 1 again, isn't it, here and here. Okay, so let's do this problem then. Bit of background done first. So let's take cosines both sides. So cosine y is equal to cosine of arc cos is just the object itself, which is x. Differentiating gives. So cos goes to minus sine of something, multiplied by the something differentiated, and x differentiates to 1. So that tells us that y dash then, take the minus over to be with the 1, over sine y. And we know sine y is 1 minus cos squared, square rooted. So here, let's just write that down, that sine y, sine squared y is equal to 1 minus cosine squared y. Cos y is equal to x, so that's 1 minus x squared. Square root both sides. Sine y is equal to the square root of 1 minus x squared. And the y value range that we're taking in this problem goes from 0 to pi, doesn't it? And we know that the sine is positive in that range, and that's why we don't need the negative square root. It's just the positive square root that is the solution here in this case. So we've got sine y is equal to that, and now we can just put those two things together. So y dash then is equal to 1 minus 1 over sine y, which is square root of 1 minus x squared, square rooted.